I'm going to do this in 4 steps across just to make sure that everyone understands. So I'm going to write f of x is going to be negative 2, oh boy, before 816, is that right? Then I'm going to write 3f of x is going to be negative 2 and 48, negative 1 and 3, 0 and 0, 1 and 3, 2 and 48. If you're sitting at your seat and saying, Mr. Sadler, I can do this faster, as long as you get the right answer at the end, that's fine. Okay, right? Probably if I was a student sitting in your chair, I would probably do 3f of 2x first. So that's one operation on the x, one operation on the y, and then do the x, and do the plus and then do the next one second, but that's okay. All right, 3f of 2x. So it's going to be dividing your x values by 2, so it's going to be negative 1 and 48. Negative 1 half and 3, 0 and 0, 1 half and 3, and 1 and 48. Next one is going to be 3f of 2x minus 2. So that's going to be adding 2 to your x values. So it's going to be 1 comma 48, 3 over 2. And hopefully someone's going to yell when I make a mistake. This is all being done in my head. But please hold anybody else. Okay, so I'm going to graph this fastly. I just can do a rough sketch in your paper, that's fine. The thing is, most of the interesting stuff is going to happen around 0. Even 48 is going to be really, really big on the page, right? So we'll graph this one on here if we can. Okay, so since the only interesting points are at negative 1, I'm going to put my line here right at the bottom of the page, hopefully. I only have to get up to from 1 to 3. I'm going to count by 1/2 on my x. Can somebody please tell me why it's probably smart to count by 1/2? Go ahead. Yeah, so I'm going to count by halves if I can. So this is going to be 0, 1, 2, 3, 4, 5. Right after 47, 2, 4, 6, 8, 10, 12, 14, 16, 18. That's like 2s. Now, if you don't have as much graph paper as I do, and you want to count by 5s or something, that's fine, as long as you can sort of see what's supposed to be happening. I was going to make it. Luckily, I just said it. Okay, now remember that x to 4 is supposed to look like a parabola more stretched up. So this should also be a parabola if we did our work right. And I think we did. So 2 and negative 1 is right there. 5 over 2 and 2 is here. And 3 and 47 is way up at the top of the board. Okay. That's very big. Then we'll do the same thing. 3 over 2 is here. And 1 and 47 is right there. Ah, almost. Not bad. Okay. I'm going to call this example 2. Okay. As mentioned, there'll be one of those on your test, one of those on your assignment. Questions and fears about this? Now, in advanced functions, I will not be doing domain and range probably for this one. Actually, well, we'll see. Maybe for these ones I would. Why might it be okay to do the domain and range for this one? And normally I don't, though. Why is this one probably going to be okay? Yeah. Yeah, you can very easily see where the minimum is, right? What's it next to the child? 6 or 5? All right, so there's example 2. I'm going to write your homework on the board and we'll call it a day there, okay? So, new homework for this tomorrow. It's homework class. I have 2 graphs. 2 graphs for tonight? I think there's 2 graphs there is around it. So the homework was page 40. What was it, number 6 ABC from a 9? And page 50, number 7, 8, and 13. 7 and 13 are graphing. 8 is just saying what the transformations are. You just write what the transformations are. So this is fairly light again yet. Okay? I love math. I love math for some reason. I'm going to ask Dexter here again. Dexter, do you remember calculus last semester? How much homework was there in calculus? A lot, okay. Calculus is a lot more speedy. This is my first time teaching the course. There's a lot more heavy duty in this course. Okay. Right, so I'm sorry that you're finding this heavy duty. I'm going to call your mother tonight and I'll say Krista can do what she wants, but I'm just going to take